Hey, so we're going to be looking at related rates, and to get us started, we're going to be looking at this problem here. So what's going to be happening is that we're in this car going down the highway. Let's say that the posted speed limit is 65 miles per hour. Alright, so there's the posted speed limit. Here's us driving, and here's a police helicopter. Now here's some constants that we're going to start out with knowing. So let's say that this helicopter is, let's call this distance A. Let's say this helicopter is 0.5 miles above the highway. And let's say it's always half a mile above the highway, so it's not going to be bouncing up and down. Alright, let's say that this, we'll call this B. Let's say that we don't know B yet. And let's say that the distance between the helicopter and our car here, let's say that that is 1 mile. Okay, so 1 mile. Oops, let's not call that B. Let's call that C. Okay. So here's what happens. So this helicopter that's flying half a mile above the highway and is about 1 mile away from us, what happens is that the helicopter clocks us going 66 miles an hour. So this is C, and remember, C is measured in miles, okay? But our speed away from the helicopter is in miles per hour, which is the rate of change. So why don't we say that our distance, so C of t, our position function away from the helicopter is C of t, and we'll say that C prime of t, which is going to be the change in miles over the change in hours, well, he clocked us going 66 miles per hour. Now, if the speed limit's 65 miles per hour, well, we weren't really going that far over the speed limit. So why did he give us a ticket? Well, remember that the speed that he clocked us at, that's our diagonal speed here. That's our hypotenuse speed. What we want to figure out is what is our horizontal speed. So just for fun, let's figure out what this length B is. Okay, so this length B, well, if I know A and I know C, then I can use the Pythagorean theorem that says that A squared plus B squared equals C squared. So that's going to be 0.5 squared plus B squared is going to equal 1 squared. And if you do the math on that, what we're going to get is that we're going to get that B is going to equal, well, I'm going to do approximately 0.86. Now remember, A and C are in miles, so what unit is B going to be in? Well, that's also going to be in miles. But I don't really want to know what B is in miles. What I want to know is what's the rate of change of B, aka how fast am I going? What's my miles per hour? So what I'm going to do is I'm going to say that all of these are position functions, just like C was a position function of time. So at this time, I am 1 mile away from the cop. So we're going to do A of t. Well, I know that A squared plus B squared equals C squared. And now if I want to figure out my rate of change, what am I going to do? Well, I'm going to take the derivative. So I'm going to take the derivative of each of these pieces. So that's going to be 2 times A of t times A prime of t. What am I using right here? I'm using the chain rule. Right, so we're going to have to use the chain rule on these. Plus 2 times B of t times B prime of t equals 2 times C of t times C prime of t. Alright, so I have a 2 in all of these, so what I can do is I can take that 2, I can go ahead and I can cancel it out. So since I have a 2 in all of these, I can just go ahead and cancel all the 2's out. Alright, great. That makes our lives just a little bit easier. Now what I'm left with is I'm left with A of t times A prime of t plus b of t times b prime of t equals c of t times c prime of t. Well, a of t, remember, that's just a. So I know that that's going to be 0.5. 0.5 times, now a prime of t, that's the rate at which this distance is changing. Well, remember I said that the helicopter was going to stay at a constant height above the highway? So what's the derivative of a constant? Well, the derivative of a constant is going to be 0, which means that his vertical position is never going to change. Plus, well, b was 0.86, which is what we found up here, times, well, we don't know how fast we were going horizontally, so we're going to leave that b prime of t. B prime of t equals, well, c, that was 1, times, and then c prime of t, we know what that is. He said that we were going about 66 miles per hour. So we're going to say that's 66 miles per hour. Alright, so if we clean this up, well, that's going to be 0. So we're going to be left with is 0.86 b prime of t equals 66. Divide both sides by that 0.86. And what we get is that our speed, b prime of t, is going to be 76.74. And what's the units here? Well, it's miles per hour. So really, we were going 76.74 miles per hour. So it looks like this helicopter had every right to pull us over.